So we are going to be enjoying a wonderful presentation by Nate Sanders. We want to thank first RoboFlow for being our lunch sponsor, and just a little bit about them. RoboFlow empowers over 250,000 developers to build their own computer vision applications, no matter their skill set or experience. They streamline the process between labeling your data and training your models. So go to RoboFlow, and here's a QR code that you can learn more about what they are building. So we're going to hear from Nate Sanders. Nate Sanders is the CEO and co-founder at Artifact, a voice of the customer analytics solution. Artifact centralizes qualitative data, so data like scientific, like your help desk tickets, your customer chats, survey responses, all of that type of data, and uses AI to synthesize the insights so you can make evidence-based decisions that impact the business. So Nate is going to be talking about what they built at Artifact. He is, brilliant, and he's going to be able to talk about how Artifact has aligned the risk of the company to innovation and followed a creative, unconventional path building a differentiated AI product. So we're going to turn the time over to Nate. I will switch screens and we'll be ready to go.
Okay, thanks, Heather.
While Nate's getting set up, just a reminder about our February event. We are going to be doing a February event as well. So the 16th, I believe, is the third Tuesday of the month of February, and also March. Those are going to be appearing on the schedule really quickly, so you'll see those announcements. And then we don't yet have April and forward, but again, every third Tuesday of the month to build the plan. So, okay, I think Nate's ready.
All right. See where my cursor is here. All right. First of all, thanks for having me, and thanks for coming to this session. It is a hard act to follow up David Healy. If any of you were here for that last talk, he did a really wonderful job, and I've learned a lot from him and ended up spending about an hour with him after that session and just learning from him. He's a really smart individual. So happy to follow up. As Heather mentioned, I want to talk today about our path at Artifact to how we've built a really differentiated AI product. And building product in startups is very difficult. The pairing of what is already a very difficult process of building great products with the fact that you're going to market with that brand new product and trying to be able to find product market fit is a really difficult journey. One of the things that I think we've done exceptionally well is that we've paired the risk of what comes with the startup space. It doesn't change. It's always going to be hard. It's always going to be asymmetrically not in your favor. And we've paired that with a really close coupling of what makes us differentiated and special in the market, and I want to talk about that today. So before I do that and before I talk about that journey, I'm going to give you some context around Artifact, why we started the company, and the technologies that existed, I think, prior to that. So in 2017, I had just started at Pluralsight, which is an ed tech company here in Utah. And one of the experiences that I had had throughout my entire career as a product manager at that point was the fact that every shop I'd gone to, we had this huge amount of unstructured data. That could be our own customer research. It could be help desk tickets, all kinds of stuff. We just couldn't make sense of it. You had to be able to use manual methods like affinity mapping, things like that to be able to make sense of it. A lot of the data science that existed around this at the beginning of my career was just not viable for trying to be able to make sense of all this data. So when I joined Pluralsight in 2017, one of the things that I was tasked with was this initiative to be able to go and help the rest of our product teams. We had about 20 product teams, to be able to help them synthesize their customer research and qualitative data that was relevant to the initiatives that they had. What that looked like essentially was going through huge stacks. I mean, like we're talking paper stacks like this big of transcripts of customer interviews, things like that, and teaching teams how to be able to go through and synthesize that data in a code-based way, code as in like qualitative coding where you create serialization and things like that that you can track back to like quantifying what's going on inside of these qualitative themes. So that was one of the initiatives that we had. And essentially what we would do is we would take all of this really vast amount of unstructured data that we had from our customers, and our goal was to be able to make that into themes. And those themes that we would use of what customers had said, we would use to be able to create artifacts like journey maps, things like that, so we could set company strategy from that data. And this process, oh fun, let's try that again. There we go. This process of taking all of this unstructured data, finding themes, and then trying to be able to come up with an idea of what the strategy should be worked really well throughout my entire career, and we saw a lot of success from this at Pluralsight of teams avoiding some risk or maybe avoiding groupthink by looking at this really clear lens of what is the evidence telling us about what customers need and want. So the problem with that is that it's incredibly expensive. This is typically what this process looks like. You have 2, maybe 3-day activities of people, 8 to 10 people that are paid $150,000 plus to be able to come into this room and build these artifacts of what's actually being said by the customer. And it's expensive, so if you run those things 3-4 times a year for different initiatives and you have 20 product teams, you can do the math as to what is the actual human capital cost that gets incurred from having to be able to do these activities in a human-based way. So really expensive, really time-consuming. It's also only a snapshot of like what's going on. So it was really painful. So I decided to be able to start a company off of that pain point. And at the time in 2020, there was some limitations based on what the methods that were available, but also there was a really clear pattern of what people were doing to be able to use topic modeling across this type of data. So a quick little history lesson of what's happened in the world of NLP over the last like 20 to 30 years, and this is way overly simplified. But in the 1990s, and you could even say in the 1960s, but in the 1990s, a lot of the term frequency models started to be able to become a lot more sophisticated. And then in the 2000s, you started to be able to get things like word embeddings and vector-based word embeddings. And then in 2018, we of course had this kind of seminal moment with transformers, and I'll get to that here in a second. So term frequency models, what were they? Why was it hard? Like, why wouldn't this work for our situation? You take a corpus of text. It could be books, could be customer tickets, doesn't matter. And every single unique word ends up being a vector representation of what's going on inside of that corpus. And the multiplicity of how often that word occurs ends up telling you this document is generally about this thing. And as unsophisticated as that is, it generally works decently well. Like if you use LDA or some of these other methods that use term frequency features, you're going to end up knowing that, like, okay, I looked at these 7 books. It says wizard and wand. It's got to be something about like Harry Potter, right? So it works okay, but it's not easy to be able to set action off of like wizard and wand, right? You need to be able to understand specifically what are customers actually saying. And the term that I'll use to be able to talk about this throughout my talk today is resolution. So the resolution's too coarse. You can't really make sense of what's being said by the customer in a way that you can actually drive towards action throughout your initiatives. And then in the 2000s, we had these word embeddings, and they're wonderful. You can take these co-occurring vectors and look at the relationship semantically of what's going on inside of those features, and allows you to be able to do stuff like this. This is a very trite word embedding example in the original paper of you can do mathematical operations over words using word embeddings. And again, even though you can start to be able to understand the semantics and what's actually being said inside of these different documents with a solution like word embeddings, it's still really difficult to be able to set strategy off of these 1 or 2 or 3 word phrases. So word embeddings themselves are still really too coarse. Even though they power all of the current innovation that sits around transformers, like they're the underpinning of what's really going on there, right? Outside of the architecture, it's really, if you use them alone, it's still too coarse. You can't make sense of what customers are saying by looking at word embeddings alone. If this will work, there we go. Essentially, what we wanted to be able to take a look at was how do we take all of this data, how do we build a really differentiated and special product that helps you actually understand what customers are saying. As we set out on that journey, there's one core lesson that I've learned, which is this. Entropy kills everything. It kills ideas, it kills products, it kills businesses. That if you do not have new energy coming into your different initiatives, which could be velocity, ideas, people, whatever it might be, your initiative will die. And the journey that we went through, I think as I look back, as a mental model, as a lens to be able to look through my experience of building an AI product at a startup, entropy is the best lens I can think of what has caused us grief, what has given us success is either avoiding or encountering entropy. So what does that look like as we've tried to be able to navigate that over the last 4 years? The first lesson is that the right people, getting the right people on the bus, building the right team, it brings new energy into your business and into the systems that you have to be able to create great products. The wrong people have a tendency to be able to try and create their own subsystems. That could be team silos, it could be working in vacuums. We'll talk about a few of those. But the wrong people tend to be able to try and create subsystems. They don't try and focus on working together. They don't try and connect the dots. They're trying to be able to specialize and silo oftentimes inside of these systems. And it's a really clear demarker of someone who shouldn't be in a unstructured, high-risk type of environment of what a startup has when you're building these AI products. So let's talk about that a little bit. Over the last 20 years, product teams have evolved a ton. I think at the beginning of my career, there was a shop I worked for where I had to go ask the COO if I could talk to a customer. Alicia Colley over here is our head of product. I would fire her in an instant if she wasn't talking to our customers. It is a no-brainer, and it is wild how far we've come over the last 10 to 15 years of protect customers, don't let people talk to them. Our team should not be actually interfacing with them because it might risk the renewal or whatever the crazy arguments we had 10 to 15 years ago around this. We have come a very far ways away from what that was. However, when you're building these AI products, it introduces a different talent stack than what this product trio has evolved into over the last 10 years. So we're all very used to UX and PM and engineering kind of building this trio to be able to build really great products. But the problem is that you have this other role now, which is like machine learning and research science and applied research science that sits into the mix. And one of the things that we found early on is that these teams, if left to their own devices from an organizational design standpoint, love to be able to separate themselves away from engineering and the rest of the organization as much as possible. There are some natural reasons why, one of which is the life cycles of how you do the work is very different. Training a machine learning model, going through the process of getting that productionized, evaluating its performance, is very different than the process of being able to ship software into production every single week or every single day. So there are differences in the life cycle, and I think that's one of the reasons that people tend to be able to just pull themselves out. But the fact of the matter is, this creates entropy. If you separate these two teams, it creates an enormous amount of entropy. If you are not a lab, you need to combine these two teams as fast as you possibly can. If you're a lab, I get it. Like you actually have core initiatives that revolve around the experimentation and a lot of different ideas coming through that. If you're not, you should be combining these teams as fast as you possibly can, because without it, you create and introduce a ton of entropy into the team. Why does that happen? Well, they start to be able to write code and implement ideas in dramatically different ways. So rather than having a cohesive way to be able to figure out how to be able to get these things into production and into the hands of our customers, we start to be able to get opinionated about, well, based on this experiment I'm running, I think the implementation details should look like X. And then you have to be able to supplement that with a ton of communication between the two teams. If you've read Jeff Bezos's I don't think it's an autobiography, but his biography, you'll know that one of his big themes at Amazon was the fact that you should actually do everything you can to limit communication in that way, because it's usually a pretty good indication that you have all these cross dependencies happening. So you should try and be able to create systems and teams that actually can limit the amount of cross communication that has to be able to take place. what we found is when we started to be able to separate these teams, the amount of communication and facilitation that had to be able to exist to keep these two teams aligned was monstrous. It was just huge. And we spent a lot of time just arguing about the semantics of my code versus your code, my situation versus your situation, what you need versus what I need. And even the premise of just building an API contract got lost in the sauce of just trying to figure out how do we get these models trained or this software product into production. So, in short, there's a new type of team that's evolving here. And I don't care what you call it. I don't care how many people are on the team. I don't care if it's 3 people or 10 people. You should do everything you possibly can to be able to get the cross-functional roles that are needed for success onto the same team. So if that means that there's a salesperson that just gives you good input for what's needed here, then like cool, work cross-functionally with that person. I don't care what the the layout or the topology of this team looks like. You need to focus on the cross-functionality and the ability to be able to decrease entropy by having everybody be on the same page, working towards the same things, even if the life cycles are different. There are ways to mitigate the difference in life cycles. There are not ways to be able to mitigate the fact that once you've introduced all this entropy and chaos into what you're trying to do and trying to be building and reducing risk inside of your company, it's hard to be able to reverse that. It's hard to be able to turn back the clock on that. Okay. Let's go back here. Yeah. So entropy lesson number 2. The results of your decisions, so actually making the decision, the moment where you actually make the decision and start working, builds and adds energy into your systems. That's the moment, that's the turning point inside of initiatives where you start to be able to feel momentum and this drive and energy inside of what you're doing. The process of making a decision decays energy. The time that you take to be able to try and make a decision will actually decrease a lot of the ability and energy that goes into building really great products. So what do I mean by that? In short, what I mean is that you should make a decision that's as good as you possibly can, as fast as you possibly can. One of the things that we do as humans that is very weird is that we trick ourselves into decision making being a binary choice. So most of us probably went to some sort of higher education here based on the demographic of being in technology, and you're probably in your senior year of high school and you're trying to figure out where you want to go to school, and you built a pros and cons list. Am I wrong? Anybody do that? Anybody build a pros and cons list? Yeah. What we know about decision making is that pros and cons lists are one of the most terrible ways you can actually make a decision, because it traps you into this binary thinking of something's wrong and something's right. So think about this for a minute. You, as an intelligent human being, have a whole bunch of options, and you whittle it down to 2. And in some chance, some way, you allowed the wrong option to make its way all the way to the bottom of the list and the right option. It's not likely. It's not probable that at the end of the day, at the bottom of that list, you have a right-wrong situation for you to be able to evaluate. What's likely is that you have 2 incredible choices. And either one, the more agonizing the decision becomes, as Sam Altman said, the more agonizing the decision becomes, it probably doesn't matter. Either choice that you make will probably end up with a very similar outcome. There are exceptions to this, where a difficult or agonizing decision can be based on the consequences that are very clear in our lives. But the vast majority of our decisions that we make, we end up trapping ourselves into this right-wrong scenario. That's a fallacy. It doesn't exist. It's both are probabilistically correct and good, and you as a smart individual allowed those 2 really great options to be able to get towards the bottom of the list. So with that in mind, if there's not this binary situation where you can have a right and wrong situation when you're building these products, then you should do everything you possibly can to be able to optimize for making the best possible decision as fast as you possibly can. So what sorts of things allow you to be able to do that? One of my favorites It's actually based on a very valid framework called the Johari window. And the Johari window started out as a social science practice for self-awareness and things like that, but it was actually used by NASA during the moon landing to be able to prioritize decisions. So what they did is they would prioritize your known knowns, your known unknowns, and then there are two other quadrants that you can't do anything about, which is unknown unknowns and unknown knowns. Those other two don't matter because you don't know about them, and there's a kind of a blind veil for us as individuals and humans that we can't see. So if you can identify those first two, your known knowns, your known unknowns, you're identifying all of the assumptions that you've made about the current initiative, about the current product, what you're working on, and you take those things that you don't currently know and you ruthlessly prioritize those above everything else. So identify your unknowns. This is surprisingly, I think, one of the most effective ways to be able to make very fast decisions, is to be able to take the time to think clearly about what do you know, what do you not know, and prioritize the things that are not clear or that you've made assumptions about, and do everything you can to be able to focus on those as much as possible. Especially in the world of building AI products, there's a ton of unknowns. So this process, I think, has helped us a lot throughout our journey. I'll talk a little bit more about this here in a second on our next lesson. Okay, entropy lesson number 3. The map is not the territory. I think it was George Box who said, all models are wrong, but some are useful. So if you think about this top phrase, the map is not the territory, this is a mental model that we talk a lot about at Artifact, which has a lot of different meanings for us. One of which is, if you think about the tense or the pretense, of a map, it's an abstraction. It's a generalization of a territory. It's not perfectly accurate, and that's the point. If it was perfectly accurate, if it was 100% fidelity, you wouldn't need it because it would be in the real world, right? You'd be walking through the actual terrain itself. So these abstractions, these overgeneralizations of what we experience are really useful to be able to make great decisions and to be able to make your way through uncertainty and high-risk situations. And the other thing is, you think about the dynamics of a team, is you have an existing team. You have this base layer of the people that you work with. And they have learned a lot about what works and what doesn't work inside of the process of the products that you're building. And then you have this secondary condition of a new team member who has their own life experiences, their own career experiences of what has worked and what hasn't worked. And you've hired that person because of those things. They know something that you needed to be able to influence the success of your product. So both parties have to be able to look at this situation through this lens of the map is not the territory. What does that mean? It means that for the existing team, they have to be open to the idea that there were things that they've already tried, or maybe some of the things that they think wouldn't work might actually be a limitation of how they did it, applied it, or tried that individual initiative in the past. For the new team member, it means that you need to be open to the fact that the things you've already experienced at your past shops may not be applicable to this one. You may not have the same outcome in this new initiative or this new company or whatever it might be by having the same application or methods that you might use. So it's important because as you start to be able to navigate the world of machine learning and AI products, as wonderful as the advent of things like transformers and large language models are, there's still an enormous amount of uncertainty. And I want to talk a little bit about what that's looked like for us at Artifact. I'm just going to back up before I jump into that. One of the things that's been really important to us, as I mentioned at the very beginning, is a topic model. So the ideal state for Artifact and the topic model that we were trying to create was this incredibly high resolution topic model. So the way that you can think about that in terms of just everyday language is that it would be more of a phrase than a single word or 2 or 3 words. So rather than, for the ML folks in here, rather than n-grams, you would have like a sentence level knowledge representation of what the customer is saying that you could cluster on and actually build these really interesting topics around what's being said. In practice, what that looks like is that instead of, I'll use one of our customers as an example, Pura. instead of them having something like diffuser Wi-Fi, might be a topic in other competitors' products. Inside of Artifact, it would be, I can't connect my diffuser to the Wi-Fi, or I've tried 5 times to be able to connect my diffuser to Wi-Fi. The specificity of what's different there allows different teams to be able to clearly understand what the problem is and actually build initiatives around what's being said by the customer. That was the target. That was the goal. And I told you a little bit about the current technologies that existed at the time. Almost everyone was using Ngrams. Frankly, still today, that is kind of the status quo of how topic modeling is done, is word embedding based Ngrams. So it's like 1, 2, 3 word phrases that you get out of this thing. They weren't good enough, and we chose as a team to be able to rally against the fact that we are going to do everything we possibly can to build a topic model that focuses on this core differentiation of this really high resolution that we're talking about. So we didn't really initially know how we were going to solve this problem. We had 2 leading thoughts. At the time, the only large language models that exist, you had GPT-2 and 3. The API access was not open for GPT-3 quite yet. So you had some open source models like GPT-J, Neo, things like that. The performance was terrible. You had to have like 10 to 15,000 examples to actually get any sort of good performance and an eval out of these models. And then outside of that is you had BERT. BERT was the highest performing, most predictably performing model that existed in 2020. So what our thought was is we could use some sort of fill mask activity using the strengths of these BERT models, and we could do one of 2 things. We could either try hierarchical clustering, or we could try some sort of graph-based method to be able to try and build these topics. So I'll talk a little bit about what that actually looked like. And I'm going to go fast through this, and the point of this kind of meandering story is the fact that we had to be very open to what could be true and changed based on our context of our previous experiences. Okay, so the first idea that we started with is we chose, instead of hierarchical clustering, to be able to go for this graph method. So what we would do is we would take these fill mask representations of a sentence. So if you imagine you have a sentence and you essentially do a find and replace for every single word in that sequence of words. So you end up with this big tree for every single word in there. What are the most probable words that could have been put in place of that? It's almost like a thesaurus for every single sentence. And then we would take, based on a softmax representation of that, we would take the most probable words and we would build a graph of everything that the customers had said. So you'd end up with these subgraphs of these different highly similar thesaurus-based representations of what customers were saying. And then our thought was, well, how often do these occur and link to similar documents? And can we create some sort of graph representation of what that looks like? The result ended up being that the cross relationships were too noisy. You end up with this almost fully linked graph of all of these different vertex and edges just converging into this big glob. And part of that is based on the nature of how word embeddings work, just because they're already very tight and concentric. But part of that was just based on the noise of the type of output that you get from these fill mask activities. So as we looked at that, our thought was, well, maybe we could construct these embeddings in a more hierarchical way based on existing graph-like methods. And one of the methods that had come out just barely based on that was just published by a guy named Andrew McCollum at UMass, and it was called box embeddings. And the unique aspect of these is that you could get these hierarchical relationships based on how the boxes all overlap. So you could kind of translate those back into a hierarchical directed graph. And the problem that we found for these was that the scalability of actually trying to compute these was factorially more difficult than just word embeddings alone. So the compute costs of trying to do this every single day for lots, I'm talking like tens of thousands of different interactions with customers every day, was just too high. So we had to move on. And as we were moving on, gosh, here we go. I actually met with a researcher at Recursion. We were interviewing them for a job at Artifact, And as I talked about the problem that we were trying to solve, one of the things that she said was, this sounds a lot like DNA knots. And I was like, I don't know what that is. I'm really flattered that you thought I would know what this is. And she explained to me that these helixes that we all think about for DNA is not actually what DNA looks like. It's actually all jumbled and raveled in its natural state. And that there's an algorithm that you have to actually untether these things into the helix that we see and think about most commonly. So you take these DNA knots, and there's these algorithms of how you can actually look at common patterns of how they're shaped. And her thought was, well, maybe you could look at the topology of the different knots of your data and find the clusters based on that. Well, one of the only ways to be able to do that is with something called persistent homology. So I met with a professor at Colorado State University who's an expert in homology, and he taught us all about persistent homology, which is actually still a really strong passion of mine. I think it's very interesting. But the idea is that you take the graph, so every one of those little dots is an embedding or a phrase, and its distance is usually based on the cosine similarity of how similar these different things are. And you essentially grow the vertex arbitrarily, and it creates these holes. So if you can see all these little holes filling up as you go through there. And as they start and end, or the life cycle of those different holes, it creates these barcodes, is what it's called. So if you see all these little lines, it creates these barcodes. And you can think of the barcodes almost like a fingerprint. So the thought was, well, maybe we could use those fingerprints to be able to identify things that have similar fingerprints across all of the corpus of this data and find the clusters. Well, the problem with that is that persistent homology is cubic, so we can't compute this either. But the professor said, hey, you actually have a really close cousin to this method called hierarchical clustering. And if you just take those barcodes and you flop them up like this, there's a non-cubic way to be able to compute this, which is with hierarchical clustering. And we meandered through this process for about 6.5 months. There was no GPT-3 API access, and we at many times felt lost in the wilderness. There were a lot of, I would say about a fourth of our team that was somewhat resistant and wanted just to be able to use n-grams or 1 or 2 word phrases because they had had experiences doing that in previous shops. And the fact of the matter is that we chose very deliberately to be able to try and avoid that because we knew that aligning the risk of the company to what made us differentiated was going to be really important. We knew that customers valued it, that they wanted it, that it was a really interesting opportunity for us to be able to chase. And it took an enormous amount of just vulnerability, being open to new ideas, new paths, what might be a situation we could encounter, some sort of new method or an ensemble of methods that could help us build a really great product. And we ended up using an ensemble of hierarchical clustering and some other methods to be able to graft all the new data every day in. But we've had to be open like this for almost the last 2 years. This topic model has evolved and continues to evolve. It's still something that we're working on. It's something that's giving Alicia and I a lot of grief right now. And it's hard. It's a hard problem to solve. But one of the things that I know has been working to our favor whenever we focused on it is this ability to avoid all of the different things that create entropy, things that take away from adding new energy into the system, make you make decisions slower, avoid being open to brand new ideas, or one of the things I think is also relevant to this is ML gatekeeping, of just thinking that because I'm the ML expert, there's not someone that's going to be able to come up with a idea or some sort of solution that would work because I'm the expert. And avoiding that sort of thinking and just trying to find what really somebody is saying behind their idea and maybe trying to find a mathematical representation of what that might look like, that sort of collaboration across the team has helped us be successful in every single situation that we've been in. So we're still searching for product market fit, and we still have, I think, ways to go on trying to solve some of the aspects of this problem that we're working on. But I am certain that the best decision that we've made as a company is choosing to be able to align all the risks that we have inside of this company to what makes us differentiated. And in order to be able to meander through that and make good decisions around that, we've had to be able to avoid this entropy that exists there. So, in short, remain vulnerable, remain open, work collaboratively, condense the whole talent stack of what helps to be able to make great products into a single team, and do everything you can to be able to make your decisions as fast as you possibly can. So with that, thank you for having me today, and yeah, it was great to be with you.
We'll take some time to ask questions.
Sure.
So those of
Yeah.
you who have questions, I'll just, bring the mic to you.
Thank you, Nate. That's very interesting. There's so much going on, and there's so much new growth. How do you, as the leader, decide? Because every time you make a decision, you refactor, that's new time, as opposed to, let's stick with the, I'm going to get some terms wrong because I don't understand this. Let's stick with the enneagrams. Let's go to the aggrobomative hierarchical clustering. But anyways, anytime you do that, it's expensive. It takes time. How do you decide, like, no, we have to commit to this and move forward when there's always something new that could be explored?
So it's a really good question. I think for us, we've looked at the company opportunity, again, more specifically about the differentiation that we could create rather than building a company. So I don't want to just build a company. I'm not interested in that. I could go build a Capiche or a Qualtrics competitor today that uses Ngrams, and I have zero interest in doing that, because I know the thing that's going to move the industry forward is focusing on what makes us differentiated and what pushes us forward in a more advantageous way. That's the thing that I think we've focused on, is we could build a company. There are things that we could do today that would allow us to be able to see some sort of, I think, faster indicator of what other people have done, and maybe build the traction off of that. But we've aligned the company's risk to, this is a thing that's actually going to move us forward and innovate in this space. So let's align all of our activities and our decisions to that. So on the nose, I would say, if it doesn't help us differentiate or innovate, we try very hard not to spend time on it. So the refactoring, the decisions that are hard around the amount of time it takes, gets simplified when you look at, is this time that we're going to spend, does it have an upside potential of actually helping us increase the differentiation of this product? That's the best way I would say of how we've thought about that, is we spend time on the things that we know make us special. And if that means an incurred cost of refactoring or whatever it might be, then so be it.
Could you talk a little bit more about how your engineering works with machine learning and research? Fundamentally, machine learning is doing research and trying things and experimenting and analyzing the results and seeing what works. And then once something sticks, they hand it off in some unspecified way through MLOps or otherwise to engineering, who implements it, right? They're fundamentally pointed different ways.
Yeah.
Do you put them on the same team? Do you have a handoff? Do you have tools that you use? How do you get those two functions aligned?
Yeah, that's a great question. So I'm going to structure my response kind of in two phases. The first of which is a distinction that I think is important between hard research and applied research. And then the second is what we've experienced around specialization and the effects of specialization. So on the first, if you were a lab, I think you inherently have to be able to split those teams out. The work that you're doing, the outcomes of the work are very different. You're actually trying to create an ecosystem and a collection or a knowledge base of this lattice work of information, right? Like we understand what works, and we can use this to be able to push something forward. If you read some of the accounts of, for instance, OpenAI and what they've done with Whisper and how that came about, and some of the reasons it was created, I think that's a really good example of that. It's a really interesting model that was created, and it seems, based on some of the anecdotes, that it was created to be able to push other initiatives forward. So if you have a hard research team, I think you have to split it. If you're an applied research team, I think there is a fallacy that we tell ourselves, which is that team is actually a research team, and they're not. They're an engineering team. If you go to Tesla and you go to the AI autopilot pilot team, are you going to see a band of research scientists that are all working over here in a corner? Or do you see an engineering organization that's working on a product? You see the latter. So if you're an applied research team, I think you actually have to be able to start behaving much more like an engineering team than you do a research team. So that's the first distinction. Why that matters. When I think about the last 3 or 4 years, one of the things that I tried to reconcile is that throughout my career, I saw that full stack engineers, or people that could generalize across the entire stack of an engineering organization and the stack that sits with that, were generally better engineers. I'm not saying I haven't met really great front engineers. I have. There's an individual who doesn't live here anymore. His name is Brett Little, but an absolutely amazing engineer, and tends to be able to focus a lot on the front end and some of the technologies that sit there, because his engineering prowess has actually pushed a lot of things forward. Things like single SPA, for example, he was one of the creators of. That being said, the generalists and the T-shaped people that are full stack engineers throughout my career have been more contributive and effective in organizations. And I've tried to reconcile that over the last few years with the fact that it felt like specialization inside of ML and AI was really needed. And I've started to be able to realize that that's not true. That it was more about clarity, and I think just like the evolution of this talent. But right now, our team, we have, for the most part, individuals who could wear each other's hats. Like our full stack engineers could be an ML ops engineer, or they could even be an applied research engineer. And having that cross-functionality and being able to work on each other's work and be able to understand each other's spheres, I think is super important if you're building an AI product. So I think the roles, the titling, the talent that you need is going to evolve, and I think it starts to look a lot like a full-stack engineering team that's solving AI products, and that's how we have started to behave, is more and more like that. And I think that's helped us actually start to be able to work together. So in short, I think like if you think about all the details that sit in there, more that we converge and start to be able to behave like that cross-functional team, that's how we work together.
So I come more from the consumer side of your product versus the creator side of this.
Yeah.
And one of the things that's driving me nuts is this company over here has part of the solution I'm looking for, and this company over here has part of the solution I'm looking for, and it ends up taking a collection to solve a problem. And with what you're talking about with entropy and cross-functional relationships, how do you treat cross-functional business relationships if where your team is working on this, if that team over there, even though they might be a competitive company, is creating a similar but different complementary solution?
Yeah.
How do you incorporate or find those ideas so that you guys can create a total solution versus a multitude of solutions where companies have to grab a basket instead of...
This is quite the water bottle. That's a great question. And Alicia over there could attest to the fact that that has been top of mind for me for the last 2 years. So there's two hard parts to that, and I think you've already started to trace some of these just based on your question, which is as a startup, you have this inherent wedge. You have a beachhead problem, which is that like you're trying to actually just gain traction on anything. And that generally means that you have some sort of point solution that allows you to be able to gain traction within a particular persona. And it's usually very pointed, narrow, smaller market focus that has the potential to grow into larger market. I think that creates a tendency to be able to have solutions that don't seem to work well together. My experience throughout my career is I've almost exclusively built product suites, and I'm very passionate about building product suites. So if you think about a really good example of that is like Rippling, that they started out with a point solution of onboarding, but they very quickly moved along the value chain to be able to piece together all the activities that create a very holistic hiring and HR solution. So they now do onboarding, they do document management, they do HRIS, they do payroll, Rippling, device management, all of the different things that sit along the value chain, they've done everything they can to collapse. So the way that we've looked about that is we tried to be very intentional in the exact same way, where what we did with the product is we tried to create a footprint of our product that could serve multiple solutions over time. The time for us to be able to get to those other solutions has been much longer than I'm happy with. But the idea is that the existing feature set that we have should allow us to be able to go serve other types of data sets really quickly. And our bigger company vision is we say we're building the customer knowledge graph. So we don't want to only be focused on customer experience data or qualitative data. We want to focus on all customer data. Everything the customer says, everything they do, who they are, we want to be able to have analyzed in a single system of record, and the analytics powering customer decisions across the business. So our decision was, how do we create this footprint of a product that you could actually start to be able to apply to the different areas of the value chain, which for us was different types of customer data. So that would be my suggestion, is I think you have to have an intentionality of thinking about a customer's value chain and how to be able to condense and collapse that across your product to be able to create more cohesive solutions. But you also have to be able to start somewhere. And I think that's just the hard part. So setting product strategy of it's clear how we can get here, that's more holistic, but starting in this particular area so that we can gain some traction, I still think is important. Is that helpful? Does that answer your question? Okay, cool. Sounds good.
Any other questions?
Thank you, Nate. It's a very nice talk. It
Thanks.
provides a lot of insights. Yeah, so one question I have is when do you just start the company back to 2017? So how do you get money to support yourself and your company?
Yeah.
And the other question, when you just started the company, how do you organize the founding team? What's your insight behind why you organize your team this way? Thank you.
Yeah. I don't know that I have I think I have answered these. I don't know that I'm a role model in some of the responses to my questions because I've learned a lot of hard lessons. On the capital aspect, we raised a friends and family angel round in very late 2019 to be able to actually start the company. And the idea with that angel capital was that we would just search a solution space and try and figure out what is this company even going to be. We had an idea for generally the aspect of what we wanted to build around, but we wanted to de-risk what the company building activity should be around. And so we raised some angel capital to be able to do that. And that was essentially just pitching my network and going through the awkward steps of asking for money. And we raised some capital that way. The first institutional round that we raised, I had learned a lot of lessons from our first time. And I ran a very specific process to be able to raise that capital, and I'm happy to be able to talk with you about that if that's of interest, and I do that quite frequently with founders and potential founders. And I think generally the idea is that you try and prioritize and meet with really high quality investors as fast as you possibly can, and the dynamics of doing so just creates more competitiveness in the actual fundraising process. That has changed dramatically in today's environment. The entire demand dynamic has flopped over the last 18 months. So it's not quite the same way as it used to be when we raised our pre-seed round and our seed round in 2021. So I think, in short, on the fundraising aspect, have a process, run a process. And then on the team side, I think we could have done a better job at this at the beginning of our company. But what I'm passionate about is I would say you have to identify the really big risk pillars of your business and hire people that can eliminate them. And they're probably going to be hard to hire. And if you hire the right person for that position, you need less people. So do everything you can to just burn down the risk of the company. Identify the things that make it really risky, and then go find people that are 1 in a million that can help you actually burn down the risk of that particular area of the business.
Thank you.
Yeah.
So any other questions?
We good? Okay. Thank you so much, Nate, for joining us and being our speaker. Like I said, if you have any suggestions for future Lunch and Learns, please let us know and connect with us on LinkedIn so you can be aware of all of the further events that we're going to have. So our next one will be in February. And thank you for coming.